Today we're going to talk about congruent figures. Congruent figures are figures that have the same size, the same shape. Everything about them is exactly the same. The matching angles are what we call corresponding angles. See how B and E are in the same position on the triangle? Those are corresponding angles. A corresponds with D and C corresponds with F. Those corresponding angles have to be the exact same measure for these figures to be congruent. Corresponding sides are the sides that are going to match up. For example, segment AC corresponds with segment DE. Segment BA corresponds with segment ED. And segment BC corresponds with segment EF. And because all of these corresponding angles are congruent and all of the corresponding side lengths are congruent, that's what makes the two triangles congruent. So they're exactly the same. So right here, this example is saying that the figures are congruent. They want us to name the corresponding angles and the corresponding sides. So we have to pretend like if we translated this, or if we moved these figures together, what would match up? Angle A would be congruent to or corresponding with angle W. They are in the same position. They would match up. Angle B corresponds with angle X. They're in the same position. And we're going to make sure that we put the correct identifying marks with this. Angle C is congruent to, this bottom right is congruent to angle Y. And angle D is congruent to angle Z because they correspond to each other. They match up. Now, that's all of our corresponding angles. See, we have 4 angles, so we have 4 angles here. So now let's do the corresponding sides. Side AD is congruent to side WX. See how they're both on the top? They look exactly the same. They're in the same position. Segment AD is congruent to segment WZ. Segment DC is corresponding with and therefore congruent to segment ZY. And the last segment, segment CB, is corresponding and therefore congruent to segment YX. And so we have a quadrilateral, which means we should have 4 angles and 4 sides. Here's another example. They tell us the figures are congruent. They want us to name corresponding angles and corresponding sides. So we're going to do this one a little differently, just for time's sake. Angle H corresponds with angle R. And so we're going to put that one little mark. That means they're congruent to each other. Now, if you'll notice, this is actually a reflection. G has been reflected over this x-axis right here. And so G is actually congruent to or corresponds with Q. And so we're going to put the 2 little marks on this one. This says that that G and Q are congruent to each other, but they're not congruent to H and R because they don't have the same number of marks. And F is congruent to angle P. They're in the same position. If we flip this rectangle back over that imaginary x-axis right here, then those 2 shapes would match up. All right, here's one for you to try. Try it, pause the video, try it on your own, and whenever you're done, turn the video back on and see if you're right. Okay, this is also a reflection, and you can see, pretend like there's this imaginary y-axis right here, and so you can kind of see how there's a reflection right here. And so you should have had angle J is congruent to or corresponding with angle S. Angle K is corresponding or congruent to angle R. Angle L is congruent to or corresponding to angle Q. And you can see after you go to J and K, S to R, you can see how it just kind of keeps matching up as you go around the figure. So angle M is going to be congruent to or corresponding with angle Phi. See how if you just keep going around the figure? And so our last angle is angle N, and it has to be congruent to and corresponding with angle T. And you can actually do the same exact things with your segments. You can see segment JK and segment RS are congruent to each other. And our next segment is segment KL, and it is congruent to or corresponding with segment RQ. And as we keep going around, we have segment LM, which is congruent to segment QV. We keep going around and we have segment MN, which is congruent to segment VT. Oops. And last but not least, we have segment NJ, which is congruent to or corresponding with segment TS. Whenever we're identifying congruent figures, we need to look at these corresponding pieces and make sure that they are congruent to each other. So if AB corresponds with DE, if they are congruent to each other, and BC, which corresponds to EF, and AD, which is corresponding to DF, all of these pieces, all those sides are congruent to each other. All of these corresponding angles are congruent to each other, then that makes two figures actually congruent to each other. Now we have this down here, this is called a congruency statement. And what I want you to notice is see how A is congruent to D and they're both first, and B is congruent to E and they're second, and C is congruent to F and so they're third. It matters what order you put this in. If you said triangle BAC is congruent to triangle, we would have to say what matches up with B, what corresponds with B, that's E. What corresponds with A, that would be D. What corresponds with C, that would be F. So what order you write these in does matter, so keep that in mind whenever we're going through these. All right, our first example on identifying the congruent figures is which square is congruent to square A. So to be congruent, the corresponding angles have to match and the corresponding sides have to be exactly the same. So as you can see, because these are squares, all of our angles are going to be 90 degrees. So we can't eliminate either one of these due to angles because they're all right angles. But you can look and see this side right here corresponds with this side here, but they're not congruent to each other because 8 is not equal to 9. So square B cannot be congruent to square A. But if you look at square C, see how these sides correspond with one another, and they are congruent all the way around. They're all the same. And so square C, so we can say C is congruent to A. Our next example for example 2 says tell whether the two figures are congruent and explain your reasoning. So we want to check, first of all, they're the same shape, so that's a good thing to look for first. If you look at your angles, your corresponding angles, see how these have one line? They're congruent. Their corresponding angles are congruent. This corresponds to this angle is corresponding to this angle. They're the same. This side length is corresponding with this side length is equal. Same with this side right here. It's corresponding with this side and they're equal. But if you notice, our top corresponds with this top and they're not congruent to each other. Same with our bottom. This 8 is corresponding with this 9, but they're not congruent to each other. So they match up, but they're not exactly the same length. So the two figures are not congruent. And I'm sorry for my writing. My handwriting on my slate is pretty bad. So we're going to say they're not congruent because corresponding sides aren't congruent. Okay, let's talk about how we're going to actually use these congruent figures. It tells us that trapezoids A, B, C, D, and J, K, L, M are congruent. They want us to find the length of JM. So this is our missing length right here. Well, if you know that these two figures are congruent, if this side is 10, then the length of segment JM must also have to be 10 feet because they're congruent, they're equal to each other. So on part B, they want us to find the perimeter of JKLM. Well, we don't have any numbers, but we know that these two figures are congruent to each other, so that means we can find the perimeter of ABCD, and that will also be the perimeter of JKLM. I know that's a lot of letters. So if you find this perimeter, that means add up all the sides. So we've got 10 plus 6 plus 8 plus 8. 10 plus 6 is 16. 8 plus 8 is 16, and 16 plus 16 is 32. So the perimeter of this figure right here is 32 feet, and because they are congruent, the figure of the perimeter of this trapezoid has to also be 32 feet. All right, here's another example to go along with this. It tells us that triangles ABC and DEF are congruent. What is the side length of EF? So we're looking for this side right here. Well, if you look, EF corresponds with BC. Another way to do that, do you see EF right here? Do you see how it's the last two letters? If you come over here and find the last two letters, that way you know segment EF corresponds with segment BC, which that comes really in handy when the figures are not oriented the same way, one's been reflected or rotated or something like that. So we know that segment BC is 8 meters, so segment EF also has to be 8 meters. And to find the perimeter of DEF, we know segment AC corresponds with segment DF, so that's a 3. We know segment AB corresponds with DE, and because they're congruent, that's also an 8. So we add up all our sides. 8 plus 8 is 16, plus 3 is 19. So our perimeter is 19 meters. All right, go ahead and pause your video and try this one for yourself, and whenever you're done, you can put the video back on and see if you're right. Okay, so number 2 says which square in example 2 is congruent to square D. So we had to go back and look at example 2, and if you look, the corresponding angles are the same, and the side lengths on this one is 9, so the side lengths on square B is 9, which means square B is congruent to square D. The next problem, problem 3, says in example 3, and so I went and grabbed our trapezoids from example 3, which angle of JKLM corresponds to angle C? So you can see angle C up here on the top right, and because these are oriented or turned the same way, angle L is the one that's going to correspond. Another way is, remember, this was A, B, C, D, and J, K, L, M. Angle C is our third angle, and angle L is our third angle. So angle L corresponds with angle C, and they're also asking what is the length of KJ. So what is this length right here? We know KJ corresponds with AB, and because AB is 8, then they're congruent to each other, then segment JK also has to be 8 feet. And that's everything I have for congruent figures.